Okay, this is probably going to be a disaster, but so what was happening is my screen won't display well on the video, so we had to move everything from a Linux box onto a Windows. I'm SSH'd into a Linux box to try to do the demo. I had to download all my slides as PDF. In my presentation, I have about half the slides skipped. When they come as PDF, they're going to be all there. So hopefully you'll get something out of this and we don't go like an hour and a half as I try to get it all working. So my name is Dan Walsh. I'm a Senior Distinguished Engineer at Red Hat. I'm guy responsible for things like SE Linux and Podman. Podman's been donated to the CNCF, and for the last couple of years, well, last year or so, I've started working on some AI projects. And so created a project called RamaLama. Anybody ever hear the song RamaLama Ding Dong? Okay, so that's where the name comes from. It's a song from the 1950s in the United States. It's kind of a silly song. Sometimes I'll play it to people, but if you go Google RamaLama Ding Dong, you'll find out where the name comes from. In the open source world, llama's sort of become the de facto word. Llama comes from Llama 3, which is developed by Meta. But anyways, so we're going to be talking about open source AI and a project called RamaLama. In the last presentation, you heard about Ollama. So anybody here play with Ollama in the past? Anybody play with RamaLama? No one's there. How many's heard of RamaLama? Okay, a couple people have heard of RamaLama, but Ollama and RamaLama are basically competitors. Okay, so we want to do everything that Ollama did. So the original RamaLama started last fall, and the developer who basically came up with the idea tried to contribute a lot of stuff to Ollama. Ollama tends to be, they call themselves an open source company, but they don't accept contributions. So they pretty much shut themselves down from contributions, and they've kind of been a little bit hostile towards open source. So we wanted to basically create a project that looked at that. So we got a lot to cover. The basic idea here is to run AI locally. Okay, run it on local systems, and you know, as a developer, I like to run things on my laptop. Right? I want to be able to run things on my laptop. So how do I do that? We also want to talk, you know, there's lots of tools out there to do that, for run AI on your laptop. Ollama is probably the most popular. That we're going to be talking about RamaLama. There's a project called VLLM that Red Hat's making a lot of noise about for running large language models. And then there's lots and lots of other tools available to do that. Where do you get your models from? So the models right now tend to come from two places. People are getting models from Hugging Face, and they're getting them from Ollama. Hugging Face is by far the largest, but one of the issues you have when you go to pull down a model, people say, I want to run DeepSeek. Okay, if you went to Hugging Face right now and said, I want to run DeepSeek, you'd find about 30 different versions of DeepSeek on there. So how do you pick which version you want to use? And do you really give a crap about which one you want to use? You just want to see what DeepSeek's all about. And then you want to also look at, right, we want to run AI on your system, but really what you want to do is you want to build apps to interact with the AI. So some of the things I'll be talking about during this presentation are tools that allow you to do that. I'm going to skip ahead. A lot of these slides are not supposed to be here. This slide's supposed to page in. I hate the way this works, but it is what it is. So why would you want to run an AI model locally? The first reason is convenience and simplicity, right? It's on your laptop. I don't have to go out and get, you know, a contract with some cloud vendor. I don't have to do anything. I just want to run it locally. Give me a command line. I can run AI locally. New AI model like DeepSeek suddenly appears. I just want to run it locally and see what it's all about on my system. Ease of integration. If I'm running on my laptop, it's easy for me to build applications to interact with it. I don't have to worry about whether I have internet, I'm on a train, I'm on a plane. I can just play around with this stuff. I can customize it. I can basically toggle some of the flags. How can I get the AI to work better on my local system? So those are all developer reasons to run it locally. From an organization point of view, if you were running a company, why would you want to run AI locally versus just, you know, go to OpenAI or, you know, use Claude or use Google's version of it? Well, the number one reason people do this is for data privacy. So you're worried. You have rules inside your company, and in some cases inside of your country, that basically say your data cannot be exposed outside of the country, or your data cannot be exposed outside of the company. So you don't want to hand your data to the AI. Probably as big an issue is cost control. If you start to fire up lots and lots of AIs in the cloud AIs, you're going to find out very quickly that you're going to get a huge bill. And if all you're doing is playing with AI, it's like, for the most part, what you have on your laptop probably can do a decent job of giving you the AI experience. And then I mentioned countries, but regulatory compliance. Right? So either your country basically says that this type of data cannot be exposed beyond the walls, or things like HIPAA compliant. In the U.S., there's a rule called HIPAA, which is about medical records. So there's certain rules about how you can expose stuff outside of the data outside of your organization. So we're going to be talking about RamaLama. Again, I'm the guy that created Podman. I've worked on Docker about 13 years ago, one of the key contributor to Docker, and then created the Podman project. So I've been really doing containers for about 20 years, different types of containing of software. So when I see AI, I just see that as a container workload. So I believe firmly that we should be doing all of the stuff we're doing with containers, all the AI stuff inside of containers. We want to be registry agnostic. So we want to, we don't want to force people to go to Hugging Face. All right, so if you have a company that basically says you can't have access to the internet, so where are you going to store your models? How are you going to store your models? Well, you probably already handle that for containers, store them in the same place. We want a GPU optimized, so we want to help make containers with GPUs work well, and then we want flexible. So let's take a I wrote a blog, this was about the time the DeepSeek came out, so this is from a security point of view, how to run, RamaLama runs AI models in isolation by default. So we want to lock down the containers that are running your AI, right? Lock down the system. So you go out and grab DeepSeek. Here, DeepSeek, let me run it down. So what are you doing? You have a piece of software that's going to take a huge complex database, and you're going to run it locally. You have absolutely no idea it's going to do it. So what do? You run it as root on your system, right? That's what everybody's doing. When you run Ollama on your system, right, that's basically you're running it locally. And even if you're running it as non-root, you're running it with full access to your SSH data. How do you know that that isn't going to cause an exposure? So the RamaLama project is built on top of containers. So we support Docker and Podman for running containers underneath the covers. We actually run with Podman better because Podman has much better features. So going forward, so most of the basic stuff you do with RamaLama you can do with either Docker or Podman. But if you really want to get into the advanced features of RamaLama, you have to use Podman. So when you fire up RamaLama, it goes out and basically looks at the GPUs you have on your system. So one of the key things, like in the last presentation, he was running an AI on his system. Well, you have to set up your system to run AI. So what we've done with the RamaLama project is we built a bunch of container images, and then RamaLama looks at your system and says, hey, you're running with an NVIDIA GPU. I'm going to pull down the CUDA container image with all the software required to run CUDA on the system. Or if it's on a Mac, it's going to go out and pull down the Vulkan image. Or if it's AMD's, it's going to pull down ROCm. So basically, it's going to go out, investigate the hardware that you're running, and then pull down a container file with the code all compiled and ready to run. So you don't have to go out and recompile everything and figure out what packages you have to get to install. It'll go out and grab a container file then. Next, it goes out and picks out the model that you're going to download to your system, and then basically runs the model inside of a container isolated from the system. We support, with RamaLama, because it's containers, from the models, we support Apple, Intel, AMD, NVIDIA, Vulkan. And because we're a fully open source project, we have lots and lots of companies coming to us to contribute code to make their specialized GPUs, or sometimes old GPUs, actually work on the system. So we're fully open. Right now we have people from IBM coming in and adding Z-series code into our stuff. And we have a lot of the Chinese companies are coming in, and they're all developing specialized GPUs, and they're all contributing to our project. So it runs on Windows because it's containers. It runs on Windows, Mac, and Linux. On Windows and Mac, it basically uses containers running inside of a VM. We also have the ability to run as no container, but then you lose some of the ability to do the stuff you can do with containers in it. Lastly, it also runs with CPU. So lots of people say, I can't run AI. I don't have it on my laptop. I don't have a GPU. In this demo, even though my laptop does have a GPU and is an NVIDIA GPU, I'm actually going to be running it with CPU. So you'll see how fast it runs with just CPU only. We talked earlier about when you say, I want to run DeepSeek, or I want to run Llama 3, or I want to run Granite on my system. What does that mean? So what we do in the open source community, Docker actually created the concept, what I call short names. So when you wanted to run, when Docker first came along and you wanted to run Nginx, you didn't have to go out and specify exactly what Nginx is. You just said Docker run Nginx, or Podman run Nginx. Well, we want to do the same thing with models. So you'll just do RamaLama run DeepSeek. And we have basically a name value pair that says when someone says DeepSeek, they probably mean this, and so we're going to pull down that. Now, if you want to specify the full URL to pull down the image, that'll work as well. But basically, the bottom idea is to get you up and running very quickly with individual models. We talked a little bit about security. I showed the article I wrote, but basically, we're taking your models, we're taking your data, that it has to be exposed to the model, say RAG data, and then put it inside the container, but the container is locked down so that it can't actually do anything special on your system and keep your data secure in this type of environment. We're also fully open to using wherever your models are, if they're stored on Ollama, if they're stored in a Hugging Face, if they're stored in an OCI. And when I say OCI, I'm talking Docker.io, Artifactory, Quay.io from Red Hat. Basically, if you have infrastructure that can store container images, we can store AI models on there. And eventually, we can store things like RAG data in those. We also support multiple different image engines. These are model tools to run models. There's a really awesome project out there called Llama CPP. That is the main tool that Docker, Ollama, and RamaLama are using behind the covers to actually light up the GPU, to actually run the GPU. That's the code that's running it. Another version of Llama CPP is something called Whisper CPP, which basically is a sound to text. So you can take a song and basically say, what are the words to this song? I can't understand what the guy's singing. And then VLM is a large project. But the main idea here is that you'll be able to swap out runtimes as they evolve. Right? AI is changing. Every 3 months, AI basically changes a lot. But what we're trying to do with RamaLama is make it really easy to swap out whatever engine you're going to use under the covers. RamaLama also has serve. So the two main commands you're going to run with RamaLama are run and serve. Serve basically serves out a REST API. Almost basically the entire AI world is built around the OpenAI REST API. So OpenAI defined an API for communicating with OpenAI, and the open source community has copied that tool. So you'll see lots of like GUI tools and stuff like that talk to that REST API, and it ends up being just as simple as just doing RamaLama serve. We've also recently added Llama Stack, and I think there's going to be a slide in here to show, we've added support for Llama Stack. Llama Stack is a tool, as a library and a REST API being developed out of Meta, Facebook, and what they're doing is they want to wire things together. So in the AI world, everybody that's just played with an AI is just interacting with that OpenAI REST API. But if you want to start to add RAG data, specialized data about your internal company, or start to interact with MCPs, which are basically services running that you can have your AI interact with the real world, you need a way of wiring those together, and Llama Stack is the evolving standard in the open source community for how to wire together multiple different services, multiple different databases, and multiple different models together. So those will both be supported. One other thing that happens when people run AI on their laptops, once they're happy with the way things are going, they want to put the thing into production. So if you're sitting on a Mac running your AI locally and then you want to put it into production onto a Linux system inside of Kubernetes, you're kind of stuck with tools like Ollama. So what we wanted to do with RamaLama is make it easy for you to just do RamaLama serve -- generate kube, and then we will generate a Kubernetes YAML that will identify the different containers and different AI models that are being used and give you a Kubernetes YAML file that you can easily put into your Kubernetes cluster. If you're going to want to run it locally on edge devices, Podman supports a tool called Quadlet. So Quadlets is running containers underneath systemd. So you can start really complex services. The bottom line here is you don't want to run RamaLama in production. What you want to run is containers in production. So RamaLama is just setting up the containers, pulling them down, defining those, and then when you want to run to production, you basically want those specifications of what containers we're running and how different things were mounted into the containers. Skipping. We mentioned VLM. I probably should skip this one, but VLM is a really incredible tool for running large AI model, large stacks, multiple different services on huge GPU farms. So VLM is sort of the standard, the most popular tool in the open source world for running them. But if you're going to run them locally on your laptop, then you have Llama CPP. So just think about those. Oh, I'm going to skip it. Quickly, everything I've talked about with RamaLama is running at the command line. Podman Desktop also has what's called AI Lab Recipes. Anybody here ever play with Podman Desktop? Everybody's heard of it, I hope. So Podman Desktop's a competitor to Docker Desktop, except that it's totally free. It's really, really good at this point. You really should go try it out. But Podman Desktop has lots and lots of different plugins and things like that. And one of them is AI Lab Recipes. And if you play with that, it'll help you get to the point where you can build applications that will interact with those APIs very, very easily. So I would advise you to go try that out. On the extended version of this, we demonstrate that. But skipping. So we've talked about AI engines, pulling down the AI models. What about your data? So the next thing you want to do when you want to, when anybody plays with an AI model, they quickly realize that the model is pretty stupid, especially about internal stuff inside of your company or inside of your organization. And so the standard tool in the AI world for basically compiling your data in a way that AI can understand it is retrieval augmented generation. And I always have to read that because I can never remember what those words mean. But everybody in the world calls it RAG. So basically what RAG does is, what you want to do is you want to take your PDFs, your HTMLs, your different types of documents, Markdown and text files and things like that, and process it into a format that the AI model can interact with. And IBM has a really cool project called Dockling. And what Dockling can do is take any random PDF, Markdown language, HTML, all that stuff, ingest it, reformat it, and output in a format that different AI models can interact with. That's the easiest way to say it. So what we've added to RamaLama is the ability to just do RamaLama RAG, give me a bunch of PDFs, HTTPs, or whatever, and we will output a container image that has a pre-compiled all your data into something that AI models can use. So our goal here is to build a tool that you could run in a CI/CD system, and as your documents evolve, you keep on cutting new versions of your RAG database and provide it out to the system. And then to serve it up, it's just a simple RamaLama serve RAG, and what that'll do is take pull down the model from an OCI registry, combine it with the AI, and pull down the model, pull down the RAG database from it, and then set up the service to combine the RAG data together. So we want to keep it as simple as possible for doing this stuff. Probably the hottest thing in the AI world right now is Skynet. No, it's agentic MCP. So you'll hear about MCP or agents, things like that. And this is all about having an AI. I wrote an article saying we have to lock down the AI. So what agentic is basically poking a hole in and allowing that AI to interact with the real world. So you'll see lots and lots of these coding programs. You see these tools that are all doing, actually writing code and interacting with files in the file system, that's all using agentic. So the next generation of tools are all going to be around, you're going to be taking all your services, adding an agentic front end to it, and then allowing the AI to interact with it. So for Red Hat, we have OpenShift. So instead of having to use a specialized tool like kube control, you could actually allow the AI to list all the pods that I have running in my Kubernetes cluster. And instead of having to run kube control to do that, the AI would be able to do it. And again, we're using Llama CPP to hook up these agentic models into it. So I've talked a little bit about Llama Stack. So basically, the logos. By the way, the RamaLama is the top one. He's, again, songs from the 1950s. He's supposed to look like a guy from the 1950s. In the US, there was a famous person called Fonzie, and that's where he's based on. And then the Podman desktop is the guy. The robot below is a Podman sail inside of a robot outfit. I don't think Llama Stack is actually a llama on top of a bunch of pancakes, but someone came up with that, fooling around with that logo. But so we talked about that. We've talked about AI. Another thing that I won't be able to demo today is the concept of multimodal. You'll hear about multi-model and multimodal. What multimodal means is I'm going to use two types of AI at the same time. So one type of AI, the really cool demo that I can't demo, is basically watching a video stream. So you can hook up your camera on your laptop to watch what's happening in front of it, and then you can ask questions. So you can have the AI interpreting with the video that it's seeing, and then you can query it using sort of a chatbot to say, what do you see? And at a show last week, we were doing it, and we said, what do you see? And I walked in front of the screen, and it said an elderly gentleman just walked in front of the screen. So I'm working on the safety measures to make sure it doesn't call me an elderly gentleman again. And the other cool thing that we were doing with it was asking it, what movie star does this person look like? And it had a very small amount of movie stars, but it's kind of cool. But the basic idea is you can run that type of application locally. And you can imagine having cameras in the future on your house and everything else where you want to do a video stream and you want to know, is it the Amazon guy coming and dropping a box off at my front desk, or is it a guy with a gun walking up to the front door, right? So you want to be able to interpret what's going on, but you don't want to do that at a centralized server, right? You're not going to have 8,000 houses with cameras sending video streams back to the house. You're going to run that stuff locally, right? So you're going to be running your AI. So it's a really good use case for how to run AI. And now we're going to see what this demo looks like. Your system will suspend now. That's probably not good. Can you see that at all? If you can't see it, then... Okay, so basically I'm running RamaLama 0.9. When I run RamaLama info, it's basically going to show you all the information. Really, you can investigate this and look around a little bit, but this is usually what we ask you to send us when something goes wrong. But basically, this is actually, in this case, we're showing that it's running on an AMD 64 box. This is a lot of the stuff that Podman info shows, so it shows how Podman is running as your container engine. But basically, it's a lot of information that you can figure out about how the containers are running on your system. So let's escape out of that. Okay. So what I'm going to do right now is I'm removing basically a small model. Now, AI models are usually huge. So what I'm doing here is basically when you do a RamaLama run, I'm doing a RamaLama pull here. That's actually going out, in this case, is going out to Ollama and pulling down a model from the system. So luckily, we're at a university with a pretty good internet, so that actually worked real fast, but that's pretty scary to run. So that's as simple as how you get models. Now, I'm going to do RamaLama list. I don't know why it's pausing. And you can see the model is in the local storage. So RamaLama list will list all the models that you've already pulled to your local system. Podman images is showing all the RamaLama. So this is a build system that I build all of these container images. So you'll see CUDA and all these different versions. And these are all available on a Quay. That's where RamaLama is pulling them from. So one of the things we do inside of RamaLama is we actually have a specialized command called dry run. And what dry run will do is not actually run the container. And I don't know how well you can see that, but basically dry run will show you the Podman command that's going to be used, or the Docker command that's going to be used to run the container. In this case, you can see that we're using Podman. I've highlighted it in red. You can also see the container image that was pulled down in this next command. So you see that we pulled down quay.io/RamaLama, RamaLama 0.9. That's the container image. That's the container image that we're going to use to run our container with, run an image inside of. This next one will actually show you inside of the Podman command. We're going to highlight in red the dropping of all privileges. So this is basically running the container as tightly as possible on the system. So we're, this process, container process, could never become root and can never get additional privileges. And when you're running an AI model locally, we even take away the network. So basically, if the AI model wanted to get the software to actually start uploading stuff to the internet, we take away the ability to use the network at all when we run the containers. Obviously, when you run them in service mode, then you have to allow more access to the system. So this is again, I'm running an AI model locally on my system. And what's going to happen now is I just loaded the Granite model onto my system, and I'm running purely with CPU. So at this point, it's actually loading the kernel, loading the module into memory, and then it's going to use CPU. And you can see this is just pure CPU. So this, if I ran this with the NVIDIA GPU, it would type a lot faster than it is right now. But to me, it's usable. It's not. Now this is a fairly beefy laptop, but if you're running on a Mac, M4, M3s, M4s, it's really spiffy. Really works really well. We support. A lot of laptops have AMD and some have NVIDIA GPUs. But again, you can use it with any CPU as well. So that was running an AI model. Now I'm going to actually serve a model on the system. And this demo is not going to work real well because I'm supposed to, at this point, switch to the next step is to switch to Firefox. So I told it to serve a model at port 8080 on my system named Granite Service. And you'll see running a RamaLama PS command. Now you're going to see the containers that are running on the system. So that actually launched a container that's running the AI model. If you do a Podman PS, you basically see the same output. And I just blew away the button. Wonderful. My demo just died because it doesn't have a display because it's set up because it's over there. And I'm doing it via SSH. Anyways, that gives you a feel for it. But the best thing would be just download RamaLama. Just go onto your system, pip install RamaLama on your system, and start playing. So there's lots and lots of additional features. I showed the Llama stack. I showed different, generating kubeyaml, stuff like that is in the demo. But sorry about the hardware. At this point, I guess I'll open it up for questions. Don't demo on Windows boxes.
We can start with the questions behind you on Slido.
People are asking online?
Yeah.
Oh, can you read the question to me? Or someone just read it?
Is it worth still supporting backporting support for all the GPUs, like performance-wise, or using like PCs with modern CPUs without the dedicated GPU?
So the question is whether it's worth supporting these, some cases 10-year-old GPUs. Again, it's open source. We don't, people come to us and say, I have this ancient GPU, and they go through the effort, and then when they come back to us and say it works well, they're attributing first to Llama CPP, usually to get supported, and then they come to us and say, can you just basically allow this one to work? And again, Llama CPP is doing most of the work, and that's basically what people have been doing. But what we want to do is enable everybody to be able to run AI. So yes, I think it is worth. If you want to do the work, if you come to us and say, "Can you support this?" I'm going to say no. But if you want to support it, you do the work.
Next one is whether it's like a viable option to run it on the old laptop and whether minimal requirements?
So depends on your definition of an old laptop. So I usually run it, the Mac I do use once in a while because I'm forced to, is an M1. So I run it on an M1. It runs, again, I wouldn't run it in production. I'm not, but it runs well enough to make me satisfied. And I'm building I want to build an application to interact with the AI model. I'm not necessarily testing out the AI model with thousands of people trying to connect to it. So yes, I think it's, if it runs on your laptop, then it's good. So.
Any questions in the audience?
Yeah. Yes.
How does command for bootstrap the mic, and you can stand in here. Do you have it recorded?
So that's command for bootstrapping the Kubernetes environment. Does it support also GPU operator from NVIDIA or device plugins, or exclusive?
Right now Kubernetes doesn't by default support. You'd have to have the NVIDIA system inside in your cluster, and you would have to basically specify, all I'm going to do is I'm going to give you the Kubernetes YAML that says, this is the image you're going to run, this is the command you want to run inside of the image, this is how you mount the models into the image, things like that. But yeah, you're going to have to, again, we're giving you an example, you're going to have to take that Kubernetes YAML file and basically specify systems that actually have a GPU that matches the GPU you're giving it. So. There is a thing called KServe, which we're also building support in for. But KServe right now is tied to VLLM. And so we're working on that, working through the ways of doing that. But I would like to, I don't care for KServe that much because KServe is actually done for machine learning. And it's sort of they're trying to squeeze in LLMs. The LLM architecture into it. I think things are going to evolve over time inside of the Kubernetes world for handling this type of model. But if you start out with the primary way people are trying to run, and I think the previous presentation was, run Ollama inside of a container, inside of Kubernetes, and then Ollama takes care of pulling the models. I am dead set against that because Kubernetes then doesn't know anything about the model. Or if you take the model and just make it a S3 blob somewhere on the internet, again, Kubernetes doesn't know it. If in the future we want to run lots and lots of models inside of Kubernetes, large clusters, things like that, and Kubernetes needs to know, no one's using that model anymore, let me pull it off the system, right? So allowing Kubernetes to understand as a first-class object the RAG databases, the models, things like that. I think that's the way we'll going forward. One thing that's been added to Podman recently is support for artifacts. So for those that don't know, most container images or Docker images, I don't like to use the Docker adjective, but a lot of people do, are basically layered tab blobs. Artifacts are ways of putting individual files, a group of files, not related to like a file directory. And that's the new way moving forward that we're going to be storing AI models and AI type content and QCOW2s and things like that can be stored as just artifacts. So you might be hearing about artifacts going forward, OCI artifacts. Now OCI brings you lots and lots of benefits, right? In that you have the ability to sign this content, you have ability to scan it, you have ability to version it. So imagine you're sending out your RAG database once a month and you're updating your RAG database once a month. Well, you want to version that, right? You want to basically say, and not force all tools to run it. But as we go out to the edge devices, all of a sudden ways to be able to go out to these registries, see that there's a new version available, have it automatically pull down and enable, things like that. So, any other questions? Is there any performance overhead for using containers and GPU? So that's kind of a loaded question. So in the real world, are containers on a Linux box? There is no overhead. So containers don't apply any overhead to a system. So the GPU is just going to be leaked in. Containers are normal processes on a Linux box. So it's not like running virtual machines. On a Mac or a Windows box, there is overhead because you basically have to get the GPU leaked into the VM, and then the containers will take advantage of the VM. What we've been working actively is to improve that. So Ollama and Docker have booted this to run with the native on a Mac, And what we're working with is to figure out how we can get that GPU leaked into it. And right now we're at about 80 to 85% performance comparable to running in native mode on the Mac. But again, my opinion is if you don't use containers from the start, you're going to get stuck on the Mac. You're not going to be able to get off into your production world. Any other questions? I am also going over to talk right after this in an AI panel. So I will be pointing out in the AI panel that I really don't know a hell of a lot about AI itself. I just know about how you probably should run AI in production. So thanks for coming. I wish the demo had worked better. Anybody going to DevConf this week? DevConf next week? Okay, I'll be doing this presentation again. You can come and actually see the presentation. Hopefully it'll work. And it won't be on a Mac. I mean, no, it won't be on a Windows. All right.